The next step to build into this is to fit the function, and that will add my enemy. So if I want to stick an enemy in, so I'm going to create a function that is titled create enemy. Put 2 parentheses after it. That indicates I'm creating a function or doing a function call. I say, hey, create enemy. Now this is calling a function that doesn't exist yet, so now I will have to define what create enemy is. This is part of the fun, I think, but I'm weird that way. We all have those things that we enjoy in life. So I say create enemy. Now I can say function create enemy. And it's still a colon void because it doesn't return anything. And what it's going to do is it's going to check and see if the magic number's been reached. If the magic number is reached, it will then spawn out a new villain to attack my helpless player. Or something like that. So that requires me to create a random number, see if that random number is equal to a certain thing, and if it is, then it will execute the code to create my enemy. So first we're going to work on that, creating that random number. And we'll write it in a little more verbose kind of language, and then show you some ways to consolidate it a little bit. So hopefully it will make a little bit more sense that way. Because a lot of the programming, when you look at other people's code, they've optimized the code so they have the least number of lines. So they take what could be 3 very understandable lines, mash them together into a single line of code, and you look and go, oh crap, I have no idea what that means. And I experience that when I look at other people's code, because if you optimize the code, you find ways to do it faster, cleaner, and neater. But in the process, it makes it less human readable. So what we're going to do right now is still keep it more human readable and then progressively optimize it so it becomes a little more efficient. So we can just create a temporary variable and say var temp number, type number, is equal to. Now we're going to create a temporary number. Now I want to create a random number, and in doing so I need to then round that number down and then check if that number is equal to 0 when I round it down, and if it is, then I can't, because when I round it down it gets rid of the decimal point. Because the way it works with Flash is if we say create my temp number and then say I create it by saying math.random, if I type math.r, it automatically will code hint to random, and I put in my 2 parentheses. Math.random generates a random number between 0 and 1. So if I want a random number between 0 and 50, all I have to do is take this number between 0 and 1 and multiply it by my desired range of numbers. Because if I take 50 and times it by 1, I get 50. 50 times 0 is 0. So those are my 2 extremes. If it happens to randomly generate 0.5, 0.5 times 50 would give me 25. So you can see that that 0 to 1 range works out really well for generating random numbers. I just take that 0 to 1. It's like a percent. I just take that percent and times it by. So 50% of 50 is 25. Because 0.5 is 50%. 0.75 is 3/4, but I don't know 0.75 of 50. That's not going to be an even number, so that won't work well for me, so I'm not going there. So this generates a number between 0 and 50. If I want it to be a chance out of 100, I would times it by 100. If I don't want a random number out of 17, gives me between 0 and 17. Because math.random will continually spawn out point 0 or point blah, 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 15 characters long. That's what it does, a 15-character random number. Now, that's not 100% random, so as far as cryptologists who do code breaking and write encryption keys and things like that, it's not a true random number, but this is more random than Flash's previous math.random function that it used to have. So it's pretty good. It works pretty well, but if you trace out the numbers, you start to see that there's almost a pattern to it, and it doesn't do everything. There's not like an even distribution of numbers. It's random, but in a weird sort of way. So if I did this, I'm just going to put in a trace statement. You don't need to do that right now with your code, but the trace statement, what that does is that sends information to Flash's output window. So it's going to show me what that number is. So if I take this number and I'm going to start out with just the random number so we can see that. So if I trace it, we'll see that it starts giving me a whole pile of numbers, and it gave me 24 numbers per second because my frame rate in my project is 24 frames per second. So every 24th of a second, it spews out a new random number. If I want to slow it down so that we can kind of see it happening, I'll slow my frame rate down to 1, run the project again, and we can see every second I get a new random number. So it's generating numbers between 0 and 1. Now to give me a more consistent result, if I wanted it to be out of 17, if I times this by 17, we'll see now my numbers. It's giving me a whole slew of numbers, never bigger than 17 and never smaller than 0. But it's giving me a variety of random numbers. That's what it does. Now this number with all those decimal points isn't going to be as useful as saying something like temp number equals math.floor. So what I'm going to do is round my number down. So I'm rounding it down, so I will get somewhere between 0 and 17 as part of this. So if I run it now, I see I get whole numbers here. Oh, missed my stop there. So you can see now I get this whole slew of whole numbers, 1, 10, 2, 4, 14, 16. So you can see it keeps going, giving me a variety of numbers. It will never give me 17, but it will give me 0 to 16. The nice part about rounding down like that is computers often start counting operations at the number 0. They don't start with 1. That's what computers like to do. So that is why we will generally utilize math.floor. So I said temp number is now equal to the rounded down version of that previous one that had all those decimal points, those kind of 15 decimal points that fell onto the end. So that rounds it down. So to make this usable, we don't really care about tracing it out all the time. And 17 is probably going to be too frequent. I'm going to do something like 50. Now, if I don't want this line of code right now, but I may want it later, I can just comment it out by putting the 2 slashes in front of it. I put the 2 backslashes right here. So right next to the shift key, // that turns it gray. That indicates it's a comment. It won't run. It's an easy way to leave lines of code in place even if you it's generally, when I type code, I type lots of code, comment lots of things out, then at the very end go back and clean up the unnecessary lines of code that have been commented. Because I never know when I may want to revert to a previous kind of chunk of code that has been commented out because I may come up with a more effective way of doing something, or I may have worked myself into a corner and have to backtrack. And if the code is commented and not deleted, I can then comment out what I'm now working on, uncomment previous stuff, and kind of go down a different path of logic. Because a lot of programming is working out that flow. You work out the logic, you try something. If it doesn't work, you comment some stuff out, try something else. And you start figuring out the path that works. It's rarely a situation, unless it's something you've done time and time again, rarely do you just sit down and start line 1, finish at line 1,000, and there's your program and you're done. You usually build it in chunks, and you start solving the problem, and then you'll work yourself into a corner and have to backtrack and try something else. That's normal. It should not be viewed as you've failed or that you're bad at it. That is normal. That happens to everybody who does code. So don't beat yourself up if you code yourself into a corner and it gets stuck and it's not working. It just means you need to backtrack and go down a different method of solving the problem. Because coding is simply solving problems. It's not some magical thing that the gifted few just sit there and crank it out magically like child genius prodigy sorts of things. It's you start out with pieces and then you make those pieces come together. And periodically you will make bad logic choices and you have to backtrack and try again. That's normal. Now I'm going to use an if statement. Say if temp number is equal to 0. So kind of approximately frame rate of 24. I'm checking a random number out of 50. That means approximately every 2 seconds it should register true, give or take. Then I'd put my curly braces. Now I'm going to just trace out a statement. I'm just moving the code up so more fits on screen. There we go. So if my temporary number is equal to 0, now you saw when I was tracing it out previously that periodically it would spawn out a 0. Not every time, but when it does, frame rate of 24, random number out of 50, that should be about every 2 seconds, it should spawn out this message and tell it to me. So I'm going to save, run it. 2 enemies were created, 3. 1, 2, 3, 4, 5. Oh, 1, 2, 3. All right, so this isn't proving to be entirely random out of every 2 seconds because it's been running longer than 12 seconds. So I might need to tweak my number a little bit on here. It also is something that using random numbers as your only means of generating game objects does not always work, especially when you have a timer in place. If you're using a timer and say giving the player 30 seconds to play the game and they have to say smash 10 bad guys, but if only 8 bad guys ever show up in those 30 seconds, it's pretty hard to win the game. So using random isn't always the best choice. And there are other strategies, other methods you can employ. But right now at the beginning, it's a pretty good one. So we're going to stick with it for now. So currently it just traces out the message and enemy will be created. That's not nearly as much fun as putting the enemy on screen. So I would encourage you, with what you know, you should be able to create the enemy each time the temp number is equal to 0. So work on doing that now.